Hello everyone. This is a quick introduction to the procedural number node I recently created. You can download the blend file from GitHub. The link is in video description. When you open the downloaded file, you will see a view similar to this. Now let's see how we can use the nodes in a new project. To be able to access the nodes, you will first need to configure the asset library, and we can do that by going to Edit, Preferences, and under File Paths you will see a section called Asset Libraries. Here you can select the folders that contain the blend files having the assets. I've already added this folder, Blender Assets, which contains our file. So now let's go to the shading workspace and open the asset browser, and let's go to the folder that we configured just now, and we can see the two node groups that are part of the blend file. I've replaced the cube with the plane, which already has this default material added to it, and I can drag the nodes into the shader editor area. There are two nodes, one for the whole number and one for single digit. You can use the single digit variant if the requirement is just to display one single digit. Otherwise, you would typically be using the float number node. The first option in this node is the number itself. You can either enter the number here or you can feed it through another node into this socket. This is keyframeable, so we can add keyframes to this number input and play the animation, or we can use another node and give its output to the number socket of this node. To illustrate this further, let me duplicate this node, but before that we'll just adjust some options. I'll duplicate this and combine the two displays using the math add node. Now we have two displays here on the same surface. I'll just change the margins so that we can see the two displays separately, the top and the bottom one. So now we have two separate displays, one corresponding to the top node and the other one corresponding to the bottom one. I'll feed the output of the value node to the number socket of the first node, and let's add a 2 radians node, and we'll also add one sine node, math sine node. So we get the value in degrees in the top display, and the bottom display will show the sine of that particular value. We can increase the precision all the way up to 6, but before that let's increase the digit count. I'll also scale this plane horizontally. Now let's increase the precision to, let's say, 6. We can see the sine value with 6-digit precision in the display below. And of course we can change this function to any other math function or any other function for that matter. And whenever we change the value, we will get the corresponding function result in the lower display. This is not only helpful in cases where you want to debug your material node setup, but it can also be used to understand the functionality of individual nodes. For example, let's say I want to find out what the ping pong function does. So I can feed its output to the number socket and change this value and then see how the output varies. So I can see that the scale is 0.5, and whenever I change the input value, the output changes from 0 to 0.5 and back to 0. Now let's look at the options of the node. We'll go back to our original file. There are a set of options. Firstly, as we saw, we can either enter the number or feed it through another node. Then there is this precision value, so I can control the amount of precision. The third is the digit count. I can go up to 8 digits, and these left right, top and bottom margins allow me to place the number anywhere on the surface without having to change the UV map. The interdigit space is for configuring the space between the digits. I can increase or decrease this space. The X and Y line widths are for changing the thickness of individual segments, the vertical segments and the horizontal segments. I can increase or decrease these values. Then this tip sharpness factor is basically the sharpness of this tip. The default value corresponds to the sharpness that we typically see in the 7 segment displays, but we can change this value. If we set it to 0, there won't be any sharpness, so the tips are flat, or we can increase them to our liking. The segment separation values will actually control the gap between the segments. I can increase or decrease this gap. And lastly, this state value will allow me to give a slant to the display. I can have both negative and positive values here. And this will also make sure that the tilted numbers are within the margins that we have specified. With this option, show leading zeros, we can show the zeros before the number if the digit count is large enough. Now let's see the output values. The first one, alpha, is just a 0 or 1 number indicating the presence of the digits, but the other value, factor, you can use to deal with individual digits within the number. For example, with this simple node setup, I can separate out the digits from right to left. So let's take a number, large number. So we can separate these individual digits by simply controlling this factor. So for example, the least significant digit will have the factor between 0 and 0.1 and so on. We can also individually control the negative sign as well as the decimal point with the same technique. This is illustrated even better with this color ramp. So I have assigned separate values for individual factors corresponding to the digits in this color ramp, and with this we can see that the digits are displayed in different colors. You can go a step further and separate out the vertical and horizontal segments within an individual digit, because for example the factor 0.1, which corresponds to the last digit, is itself divided in two parts, one for horizontal and one for vertical segment. So you can use that to separate out the vertical and horizontal segments if needed. I think that's it for now. I hope you have fun with this node. If there are any questions or suggestions, please leave a comment on this video. Thank you.